Hi, Dr. Callahan here. How are you guys doing? Welcome to ProbStats for week 2, Monday. So this is your 3 questions for the warm-up. We'll be back this Friday, so you will get a warm-up log. But for the time being, if you just write on a separate piece of paper and just hold on to it, remember you guys get 1 point apiece for each of the questions, and you get 300 points for 100 for participation, 100 for preparation, and 100 for the warm-up block itself, and that's due on week 9 Friday, and today is week 2 Monday, so you have plenty of time. So question number 1, do first impressions really matter? When going to a job interview, what kind of attires should you be wearing? Question number 2, historically at Huck High School, 1 in every 2 students would drop out sometimes throughout the 4 years before they graduate. Why is that, and why do we have such a high dropout rate? What do you think? Question number 3, go ahead and graph these 4 different inequalities on the line. Okay, so here's question number 3. And for question number 3, do keep in mind that going back to Algebra 1, if the compound inequality, which is that weird little side triangular shape thing, if it is like this or this, where there is no equal sign, it's also always an open circle. However, if there is an equal sign, you use the compound inequality like a closed circle. And if it is eating the letter X right here, you always shade to the right. Whereas if it's eating a number, so think of the inequality sign kind of like a mouth. So I'm drawing little teeth right here. It doesn't look great, but that's okay. And then you shade it to the left, okay? So then looking at the first question right here, it is a closed circle and it's going to be shaded to the right because it is eating the letter X. Question number 2, it is an open circle and it's going to be shaded to the left because it is eating the number 2 and not the letter. Last one, this is a compound inequality where you have 2 different inequalities together. And if you were to go ahead and take the 2 previously and put them together like this, that will be a compound inequality. You're essentially taking the first example, the second example, and then seeing what they are, where they're overlapping. So this is an and inequality. All right, so the last time I saw you guys, this is what you should have done. You should have completed my notes. You should have created your own box on Whisker with your 8 different datas. So we're done with that. There was a Quizlet match that you could have done, and then also your homework on the Beatles. And so all together, you should have those things completed. Make sure you just hold on to it, and when I return on Friday, I will be collecting those and grading them as well. Okay, so with that said, let's go ahead and get started with today's stuff. So today's objective is going to be on 2.1, which is on basic set concept. So this is essentially like the start of ProbStats. Everything else we've been doing is kind of like a review from Algebra 1 and Algebra 2. So there is a Quizlet right here that I want you guys to complete. There is a YouTube video. There's actually 2 of them that you need to watch. And there's a Kahoot on set notations. And then that's pretty much it. So your homework tonight is going to be right here. And I know you're like, well, I don't have a textbook, Callahan. Well, guess what? That's okay, because right here where it says need to make up your word probability and statistics skills activities, this is the link that is your Google Doc, and you have all of your stuff here. I actually have photos of the work that you need to do for your homework assignment, and then also all of these links right here that you're like, great, I have to go ahead and type all of this in with all these capital, these letters. Well, no, you don't have to do that. So the only thing you need is this link right here, and this is a link you'll be using for the remaining of the semester, and it's a capital C, capital U, capital W, lowercase, it does matter, so make sure you're careful with that. So if you go to that link, it is going to take you to this page right here. And you can use this whenever you need to make up any of your assignments in my class. So this is semester one. If you look over here, it says week one Monday, week one Tuesday. So anything that you need for this class is right here, including my videos that I make and I put on YouTube. So you scroll down to week two Monday, because that's what the lesson's on. And if you look over here, ta-da, all of the link that you need for today's stuff is right here. And then you don't need to have a textbook, because your homework is on page 55 to 56, 2, 4, 6, 8, all the even numbers until up to 52. And here is a photo of what your homework will look like inside the textbook. So no textbook needed. And if you continue scrolling on, these are all the stuff for week 2 Tuesday, all the way down to the very end, which is 87 pages, by the way. And you pretty much have all of your homework assignments already completed on this link up to week 14 Wednesday, and so on and so forth. So yeah, so make sure you guys have that link for the Google Doc. And when I return, you guys will also have like little stickers that will be given to you guys. So it's a little bit easier to know where to go for that. All right, so let's go ahead and get started. I have a video right here that is going to be on different type of notation. This is an elephant of. This is not an elephant of, which essentially means that if it is an elephant of, it means whatever number it is inside the set. This means that whatever number I'm talking about is not inside the set. This symbol is a subset of. The U is a union of the set. This is intersection of the set. And this symbol is an empty set. All right, so section 2.1, those are the objective. I know there are 8 of them, so I'm just going to give you guys a second to read it to yourself. Pause it if you need to. All right, so let's go ahead and get started with our notes. Okay, you should have this in your guided notes. And it is 2.1. So sets, a collection of objectives whose content can clearly be determined, events or members or objects in a set. A set must be well defined, meaning that its content can be clearly determined. The order in which the element of the set is not necessarily important. Methods of representing sets. Go ahead and just read that. For example, a set is symbolized by W, which is week of the set. And if you think about inside of a week, well, there are 7 days. It could be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday. So example 1. Write a word description of the set below. If you look at your set right here, you have Washington, Adam, Jefferson, Madison, Monroe. Hopefully you know that those are all presidents of the United States. So I could say set P is a set of the first 5 presidents of the United States. So example 2. Now we're going to do the reverse of that, okay? Set C is a set of coins with a value of less than $1. So think about all the coins in the US, dollar, where we're actually having a coin shortage, but think about all the coins that's less than $1. So here I'm going to say, here's my set C is equal to, and I do this little squiggly thing on the side, and I'm probably include a penny, a nickel, a dime, a quarter, and a $0.50. And those are all the coins inside the set that is less than $1. The empty set. It's also called a no set. It's basically saying that the set does not contain any elements. It is represented by this weird little symbol with like a circle and a diagonal slash. The empty set is not represented by the empty set. The notation represents a set containing the empty set element. These are the examples of the elements. So set of all numbers less than 4 and greater than 10. So going back to our warm-up, remember if it's less than 4, that means you cannot include 4. So any number smaller than 4 but not including 4, such as 0, 1, 2, and 3. And then greater than 10. So not including 10, because remember it's an open circle, and it's going to be bigger than 10. So 11, 12, 13, and 14. So is there anything that is going to be smaller than 4, but also bigger than 10? Is there any commonalities here? No. So this is impossible, and therefore it is an empty set. Because you can't have a number that's smaller than 4, but then bigger than 10. It just doesn't happen that way. Example 4. Which of the following is an empty set? This is not an empty set because it does contain the element of 0. For B, oops, I guess B got skipped over. That's okay. We'll just go to C. X is a number less than 4 or greater than 10. Well, you can't have a number smaller than 4 or bigger than 10. It just doesn't exist. So it's an empty set. X is a square with 3 different sides. Well, you can't have that because that's going to be a triangle. So that is an empty set. And I'm actually going to go ahead and fix this because I want this to be done perfectly. So give me a moment while I go back and change this. Okay, now that I fixed this. All right, so 0 is a number, it's not a set, and it's not an empty set. All right, so now we're good. Okay, so now we're going to talk about notation for set membership. This symbol is used to indicate that an object is an element of a set. The symbol, kind of like a E, is used to replace the word is an element of. The E with a little diagonal cross is used to indicate that the object is not an element of a set, and the symbol, this right there, is used to replace the word is not an element of. So let's do some practices. It says determine whether each statement is true or false, okay? So R is an element of A to Z. So think about it. Is a letter R in between A, B, C, D all the way to Z? And yes, letter R is an element of A to Z. So it is going to be true. Let's take a look at the next one. 7 is not an element of 1, 2, 3, 4, 5. That is also true because 7 is after 6, and 6 and 7 and 8 are not inside the element. So that will be true. C. A is an element of A and B. That will be true because A is right there. Example 6. Ellipses, the 3 dots after 5 indicate that there are no final elements and that the list goes on forever, okay? So express each of the following set as using the roster method. Set A is a set of natural numbers less than 5. So you'll just put A is equal to numbers smaller than 5. But because it's less than, you cannot include 5. So that's only going to be 1, 2, 3, and 4. And then you just stop right there. And this is roster notation or the roster method. Okay, so we're kind of working backwards. Set B is a set of natural numbers greater than or equal to 25. So bigger than or equal to, because there's a word equal to, you do include the 25. So 25, 26, 27, 28, and I put dot, 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 and those dots where it says 3 dots indicate that there are no, it just keeps going, goes on and on, okay? All the way to positive infinity, which is like a bazillion. C. X is an element of n and X is even. Okay, so we're going to include all the even numbers such as 2, 4, 6, 8, 10. And you can go ahead and put the little dot, dot, dot all the way to infinity. So it just keeps going. Go ahead and go over this part right here with all of the notations, and it does review the inequalities as well. Okay, example 7. Express each of the following set using the roster method. X is less than or equal to 100. So you have to include 100 in here and everything below that. So I would just say 1, 2, 3, 4, dot, 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 all the way to include, all the way to 100. And notice you're including it. So that would include everything in between there, such as like 99, such as 89, 80, etc., etc. And this keeps going. B. 70 is less than or equal to x, which is less than 100. Because there's an equal sign right here, that means you're going to include the 70. There's no equal sign to the 100, so you're not going to include the 100. So you can include up to close to 100, like 99.9. Example 8. The cardinal number of set A is represented by n of A is the number of distinct elements in set A. So for example A, find the cardinal numbers of each set. So your cardinal number is n of A. How many numbers do you have in here? You have 4. So it will just be 4. For B, it will be n of B equals 1. Why is a 1? Because there's a 0 there and it's just one number in there. N of C is going to be, you just have to count. How many numbers are there between 13 and 23? There are 11 because we count from 13 to 23. There are 16, 17, 18, 19, 20, 21 in between them. And so if you count them, there's a count of 11. And these are your answers. All right, you guys, that is basically it for sections 2.1 for week 2 Monday. I will see you guys next time. Have a great week.